Hello everyone, back after the break. My name is Jonathan Meier and I'm software engineer working with the CityEngine team for a bit more than 2 years now. And I'm super excited to have the opportunity of presenting the latest and greatest feature of the upcoming CityEngine 2021.1 release. What a tongue twister. As usual with our minor releases, our new features are mostly improvements of features we introduced in the previous CityEngine 2021 release. For such features, I'll start by briefly reviewing what's been previously available and then explain the improvements we introduced. All right, so let's get started right away with the most important thing first. CityEngine 2021.1 will finally have a nice taskbar application icon. The past few releases had have an ugly icon with black pixels around the blue hexagonal logo. Maybe you didn't notice, maybe you didn't care. I noticed and I was bothered because I think CityEngine deserves a shiny taskbar icon. So I went ahead and fixed it, which was surprisingly difficult given the seemingly trivial problem. Yeah, so CityEngine is back on the shiny side. All right, jokes aside, now let's dive into the truly important topics. So in the previous release, we introduced an incredibly powerful new tool option to the transform tools, and it's called the adjust position and orientation option, and lets you create an ad hoc custom reference system for the move, rotate, or scale operation that you want to perform. Previously, you were limited to 2 pre-computed reference systems, the global and the local one, and this was unnecessarily restrictive because for both the move and the scale tool, the orientation of the reference system is important if you want to move or scale along a specific axis, for example, along the edge of a street. Moreover, for both the rotate and the scale tool, the position of the reference system is crucial for the operation because you rotate around that point or scale inwards or outwards from that point. So here's a nice illustration of such an ad hoc custom reference system. We have a group of 2 benches and a street lamp, and if you use the global reference system in the rotate tool, we can only rotate around their center point. So now let's place this custom reference system at the center of this plaza. And what we can do now is easily place a bunch of benches concentrically around the plaza center. How cool is that? So that's what you already could do with the previous release. And now for this release, we have another example. So here we want to move around this dormer along the slanted roof. Both the global and the local coordinate system aren't particularly helpful here. And again, we can set up a custom reference system that coincides with the roof plane. Fortunately, there's a lot of snapping targets helping us position the reference system. In the previous CityEngine release, you would have to create 2 guides from 2 edges of the roof as snapping targets for your custom reference system. This is now not necessary anymore with the upcoming release. So you can just place the custom reference system here at this vertex, and then it will automatically snap to adjacent faces. So here you can see how the blue axis snaps to the slanted roof face when it lies inside it. And of course, now it's easy to move around the dormer on the slanted roof as desired. Okay, let's move on to terrain editing. We made 2 simple terrain editing brushes available in the previous CityEngine release, and they let you interactively set the terrain to a specific height or reset the terrain to its original height within a configurable brush radius. In this example here, we would like to model a hill outside this medieval city. So let's do that. Choose this the terrain edit brush with a height of 40 meters here. And yeah, unfortunately, the hill doesn't look very natural with these hard edges. And so in the upcoming release, we introduced smooth border options. So you can choose to smooth out the borders within a defined range, and then it will get yeah, much smoother, of course. Here we chose we erred a bit on the big smoothing range side. So let's just half the range here, and then we can finally model a very nice hill outside this city. Let's place a footprint on top of it. And apply the Parthenon rule. And just like that, we built a nice temple for the people of this city. So since these border smoothing options are so handy, we also integrated them into the aligned terrain to shapes functionality. So it would have been even easier to just draw the building footprint first, and then move it up a bit. And finally use align terrain to shapes with the new smooth border options. To arrive at the same result. So here are the new terrain editing border options. You can smooth within range, and this just interpolates between the existing and the new terrain height with the specified border. And then there's optional, you can turn on easing, which will avoid creating sharp ridges. That's been used in the previous example. And then there's another, the constant gradient smoothing option, which will simply apply a fixed slope specified in degrees. Notice here the difference between the smooth within range and constant gradient border. So moving on to 360 VR. Alongside the previous CityEngine release, we released the ArcGIS 360 VR web viewer. And now it's possible to easily export, preview, and share the popular 360 VR experience all from within CityEngine. In this example, we see how our Pompeii scene is exported to 360 VR. You can choose which of your bookmarked views you want to make available, and also if your scene has different scenarios, you can configure which of them should be available. Each view will be exported for each scenario so that you can easily and freely switch between scenarios and views in the VR experience. So let's finish the export here, and then the resulting 3VR file can be easily uploaded to ArcGIS Online via the Share As functionality. From there, you can further share the direct link to the web viewer with other people. This link can be directly opened in the built-in browser on any of the popular VR headsets. So there's no need to install any additional software or whatever. It's really just sharing this link, and you'll end up in the 360 VR experience. That's super, super cool. And before publishing your VR experience, you can also use the Open With context menu or a double click to preview locally how this looks on the web. Here you can see you can switch around between views, and up top would be the scenarios would be available if you exported multiple of them. So that was already possible with the previous release, and now for this upcoming version, we introduced the possibility to control the rendering options used for the export. So we added the new rendering settings option in the export dialog, and the list to choose from contains a default settings entry, and for each open 3D view an additional entry. And the default settings entry is just a fixed set of options that we think will work good in most situations. But if you want finer control over the rendering settings, you can configure one of the 3D views to match your expectation for the output and choose that view from the render settings list. The export will then be rendered with the settings of the viewport. So it's really what you see is also what you will get. So that way you could, for example, export a VR experience that has no texture shading, but adds the wireframe instead. So it just can be seen on the right-hand side here. That's it for 360 VR. Let's move on to materials. And setting up materials has been quite verbose in the past in CGA. As you can see here, for each of the material attributes, you had to call set separately. And in the previous CityEngine release, we provided a new set material operation that accepts a string array, which can a bit more compactly pass a material description. And also you just have one, you can pass around a material description in just one object. Combined with the read string table operation, you could also actually store an entire material description in a CSV file. However, while using CSV files to store materials sounds promising, the approach is still quite limited because referenced files for the different textures have to use absolute paths. So if you want to share a material with someone else, they have to make sure to use the exact same paths in order for the assets to be correctly resolved. So each of the 3 rules here produce exactly the same model seen on the right-hand side here. And now in the new CityEngine release, in the upcoming release, we have a solution for this. And this is the CGA material exporter and importer. In this example, we have 2 spheres, one with a glass material on the right-hand side and one with a metal material. You can see that definitions up here. So the glass material is essentially just sets a fixed color and some transparency value. And the metal material is a more advanced PBR material. So notice here how the name attribute is used to actually give these materials a name. Also, the metal material uses textures for the color map and the roughness map. So let's select these 2 spheres and proceed to a model export. And now here you can see the new entry, the CityEngine CGA material encoder. This encoder will create a folder for each material in the selection containing the material description in the form of a CGA mat file. And most importantly, alongside it, all the reference textures will be stored as well. So now sharing these materials is actually just as easy as just copying around this folder and pasting it somewhere else. Now we're opening a new scene with a simple rule that can consume such a CGA mat material definition using an attribute. So for example, here we use the glass material and we have a building out of glass. Or if you fancy a building, a metal building. Now looking at the code, this is as easy as just invoking the read material operation on the CGA mat file. So the material file is the attribute that is consumed, and handing it over to set material. And this will resolve the textures relative to the CGA mat file, and yeah, everything works as you would expect. So you can also just simply drag and drop a CGA material file into the CGA editor, and it will provide the set material and read material calls correspond to loading this material. So actually now it is finally really easy to build and share an entire library of materials that can be easily consumed. That's a really cool feature, I think. Okay, moving on to the next feature, and this is something completely new in the upcoming release. Namely, we support importing and exporting files in the IFC format for visualization purposes, which means that we can read and write the geometry and color information of IFC files. IFC is a widely used and openly specified format to exchange building information, modeling data, short BIM data. Now, what's interesting about our new IFC importer is that the hierarchical group information of the IFC model is made available via the geometry groups function in CGA. This lets you write fairly simple rules with powerful filtering capabilities based on this grouping information. Let's look at an example. We will use this building model opened here in the BIM Vision IFC model viewer. So here we're selecting different stories here just to get an idea of what this model is composed of. And now in CityEngine, we have a simple filtering rule that we apply to an initial shape. The rule is generic and takes the IFC model as an attribute. Internally, the rule uses the I operation to insert the model. I'll show the code in a minute. Here and as you can see, we imported this model successfully. And now here we list all the group names that are available, and we can start filtering based on them. So here's the filter, and now we can filter according to stories. Or individual parts such as doors, windows, walls, and so on. Down here, our rule conveniently lists all the selected parts, and we can color them. For example, we color all windows randomly. And just like that, we have a CGA disco. Yeah, now we can recolor with our rule, we can recolor all the different parts, and this is really just a simple example. You could also go and apply rules to different selected parts of the model and so on. Then we disable the other elements, which are the cars down here, and finally we can close the circle by exporting back to IFC. So here's the rule that accomplishes this. It's really a small rule. Here you can see the insert operation and then the component split that breaks up the model into its different parts. And we made sure that under the hood, all the CGA operations preserve group names. So you can see how the filtering is done here using string operations on the group name, actually after the component split happened. So note also here the use of local variable, and they were introduced in the previous release, and they can simplify code a lot, such as in this example here where we reference an index that we computed once. Yeah, so as you can see, CGA evolved quite a bit from being a language to generate geometry to a language that also supports impressive data processing tasks. And the keyword data processing brings us to the last topic, because there's one more thing. Let's have a look at what happens if you use get map data, head over to Berlin, set our extent here, and then import elevation data, terrain imagery, footprints, and all with default settings in the upcoming CityEngine release. Yeah, so this looks familiar from afar. The footprints are imported and then get extruded according to the height information from the OpenStreetMap data. But now let's take a closer look. you can see that certain buildings have a much more detailed models, such as the Brandenburg Gate here, for example, or the Berlin Cathedral. So our OpenStreetMap importer now imports all building parts, and we extended our building from OpenStreetMap Rule that is automatically applied if you choose so, that we ship with the Esri lib. We added a new level of detail attribute here. Level 1 is just the extrusion that we already had previously, but level 2 leverages additional OpenStreetMap tags if available to generate a rich building model. Tags are imported as a 2D object attribute array with the footprint shape. They can also be adjusted, for instance, here to recolor the dome roof if you understand how these tags are mapped. And yeah, since we provide the source code of this rule, you can also dive into the code and have a look how these OpenStreetMap tags, first of all, which of the tags are, and then also if you're interested how they are interpreted, there's this list here. So finally, here are two more examples where the increased level of detail makes a huge difference. The famous St. Basil's Cathedral in Moscow on the left-hand side, and the tallest building for more than 10 years now, the Burj Khalifa. Yeah, so these were the most important features to become available in CityEngine 2021.1 next month. To briefly recap, we introduced snapping to adjacent faces when setting up ad hoc custom reference systems. We added border smoothing options in the terrain edit brushes and the align terrain to shape command. For 360 VR, we let you control the export render settings. The new material encoder and decoder finally make managing and sharing a set of materials a breeze. With the new IFC importer and exporter, you can visualize and manipulate the geometry and colors of your BIM models in CGA. And finally, with the enhanced OpenStreetMap importer and the new level of detail settings in the building from OpenStreetMap Rule, we can generate much richer building models when the corresponding OSM tags are available. Of course, there are many more smaller features and a lot of bug fixes, such as restored support for ArcGIS Urban, which will be published in the release notes accompanying the release next month. Yeah, so this concludes my presentation. Thank you all for your attention, and I hope you can't wait to get your hands on CityEngine 2021.1. Woo!